I, and mu x equals to is the mean of random variable x, and probability of x equal to xi is the probability that the random variable will be outcome. Now, how to calculate the variance and standard deviation? So, variance of x is equal to rho square. Because we are calculating the expected value, so you can also modify the formula summation of I 1 to n xi minus ex whole square into px equals to xi. So, standard deviation, you know that under root of variance. Now, here again same, xi is the value of random variable for outcome I, and pxi is the probability that the random variable will be outcome I. And what is ex? Ex is the expected value of the discrete random variable x. And standard deviation and variance, you know that rho square is the variance of discrete random variable, and SD standard deviation of the discrete random variable x. Solving the, I am giving you the problems solving the road accident problem, because I already mentioned the road accident problem here. So I calculate according to formula. All x is given, probability value is given, you can multiply xp, x minus ex, xi ex ka whole square, and then you can multiply by pxi. So ex, the average number of accident per day, equals to 2, and the rho, that is standard deviation, equals to 1.183 to 1597. Now here I again take second example, x down 5. You can solve this, economic conditions are given, you can calculate the values. My question in this question, but what is the relation between the two investment, because here investment data is given, so you calculate and find the values. Now my next part is a covariance. The covariance measure the strength of the relationship between two numeric random variable x and y. So covariance of x also represent rho xy equal to summation of I varying from 1 to n xi minus eix in the bracket, first bracket, into second bracket yi minus ei bracket complete pxi yi, where capital X represent here discrete random variable x, xi equal to the ith outcome of the discrete random variable, y equal to discrete random variable y, and xi equal to the ith outcome of the discrete random variable, and pxiyi equals to probability of occurrence of the ith outcome of x and ith outcome of y. Here I varying from 1 to finite n. It means covariance, a positive covariance indicate the positive relationship, and negative value, it means negative covariance indicate negative relationship. And suppose your covariance is 0, indicates that the two variables are independent. So the two investment, according to calculation of covariance, is investment equal to minus 19,275. It means indicate the negative relationship, which means the two investment are varying in the opposite direction. So you conclude that when the return on the investment is high, typically the return on the other is low. Now how the mathematical model for probability distribution. So probability distribution is a mathematical model describes the probability of observing various values of a random variable. The formula of this equals to fx equal to 1 upon standard deviation into under root 2 pi whole into e to the power minus 1 by 2 in mod x minus mu upon standard deviation the whole square. Here mu represent mean. Now the diagram, according to diagram, it is very clear. So the upper red line going to say that this is the mode median, and the probability distribution distributing first part is a discrete and second part is a continuous. Again discrete is divided in binomial, Poissons and hypergeometric, and continuous series is defined as uniform, normal and exponential. So now we are summarize what today we are teaching here. So what you are understanding here. So the first, a discrete random variable, and second is a continuous random variable. So what is a discrete random variable? Counts occurrence has a countable number of possible values, has discrete jumps between successive values, has measurable probability associated with individual values, probability is high. So according to example, according to diagram, that is a discrete random variable, and in the continuous random variable measures example height, weight, speed, value, duration, has a uncountable infinite number of possible values. Second, moves continuously from value to value, has no measurable probability associated with individual value probabilities area. Now, I think all of you understanding my second chapter. Now, the next chapter we will discuss after some time. Thank you.